So before we get started on this one, I'm going to have to apologize to you in advance. I hate apologizing, but I'm going to have to do it. And the reason I'm apologizing is I'm apologizing for my laziness in that I did not actually write the instructions out for this problem because they're too long. It's like a full-length paragraph, and I didn't want to deal with it, so I'm sorry. I have copied the diagram to the best of my ability. You'll see that even that was subject to my laziness, as it's definitely a big mess. So what I'm going to do is I'm going to read through this for you, and hopefully you have this problem in front of you. But number 17 on page 418 reads, the flag shown above is made of overlapping equilateral triangles ADF and BCE. Because ribbon is to be sewn around the entire outer edge, it is necessary to know the perimeter of the flag. If CD, DE, and EF each have length 10 inches, what is the length in inches of the perimeter shown in bold? So I'm just going to make a little note here that we're going to be solving for the perimeter. And the reason I'm noting that, did I even spell that right? It looks funny. I think it's right though. So the reason I'm noting that is because since I didn't write the problem down, usually I would just circle what we're solving for. But I'm just writing this down to remind myself what we're solving for, and we're solving for this outer perimeter that I'm outlining here. And they talk about a flag and a ribbon, and they have all this extra information. I guess they're trying to make this problem applicable. We try to do that a lot in math. We try to make word problems that might seem like a problem we might actually come across in real life, but unless you deal with flags and ribbons in real life, you're probably not going to come across this. Okay, so we'll ask our who, what, when, where, and how questions, starting with the what. What kind of question is this? Aha, it's geometry. We see a figure. We're solving for perimeter. This is a geometry problem. The when question, how much time do we have? Probably not very much, considering this is 17 out of 18 on this section. And then the where question tells us that this is going to be a hard question. So then the how question, how are we going to solve this? Well, considering we don't have answer choices to work with, the best way to solve this is the way we solve a lot of geometry problems, which is labeling the diagram and maybe using some geometric theorems and possibly some proofs to solve this thing. And the reason we might have to use some proofs and some theorems is because we're told that the figure is not drawn to scale. Doom, doom, doom. We hate it when we see that on a geometry problem because it's so nice when it is drawn to scale. But in this case, we cannot assume that. So we're going to have to make sure we calculate everything and figure out exactly what it is. So what I'm going to do, and feel free to do this on your test as you're doing a problem like this, is I'm going to flip the diagram so that it's easier for me personally to work with. I don't know if this works for you, but it works for me to have the diagram kind of facing this way. I don't know, I just like the looks of it better. By the way, I skipped the who question, which is, are you going to do this problem or not? And remember, that's only something you can answer, but we're going to go ahead and do it. So the first thing we're going to do for a geometry problem, like always, is we're going to mark what we're given. So we're given, first of all, that triangle ADF is an equilateral triangle. So how am I going to mark that? ADF is equilateral. So I'm going to mark that with my tick marks to show that all of these things are equal. Okay, cool. And I probably should have gone like that to show that I was referring to that side. Okay, and then we're also told that BCE is an equilateral triangle. All right, so how can I mark that? Well, same way, but now I'm going to do double tick marks to show that those aren't necessarily equal to each other, right? They didn't, it looks like it, but we can't assume this thing is drawn to scale. They didn't tell us that triangle ADF was congruent to triangle BCE. We just know that those are equilateral. Okay, The other thing I can label with equilateral triangles, we don't know if it'll help, but we know that all equilateral triangles are equiangular, okay, whatever. All the angles are equal. All three angles are equal for equilateral triangles. So I can mark that as follows, again with my tick marks, double tick marks here. Do I need the double tick marks though? That's a good question to ask. Did I get too careful? Well, yeah, I actually don't need the double tick marks because for equilateral triangles, every angle is 60 degrees. No matter what, that's always going to be the case. So better yet, let me label these all as 60 degrees. 60 degrees, 60 degrees, 60 degrees, 60 degrees, 60, and 60. So that may seem redundant until it's not. That might be helpful. Okay, so then what else do they give us? They give us CD. CD, where are we? CD, this little guy here. All right, I'm going to switch colors. Here we go. I'm switching colors to make this easy. Easier to see. Easier. All right, CD, they tell us, is 10 inches. I won't put the units in there, but that's 10 inches. Then they also tell us that DE, which is this guy, is 10 inches. And then EF, where's EF? EF is 10 inches. All right, so that's pretty cool. That helped us out. Okay, and from here, it's really just recognizing, once we have all of our givens in place on the diagram, we can actually solve this. We can. So that's pretty cool. It's just recognizing what's what and trying to apply it. Remember, we're solving for the perimeter here that I just outlined. Okay, so let's talk about this triangle in here that I'm outlining. And I'm going to label this point right here as G, just to make it easier as we talk about this thing. So looking at triangle EGD, what kind of triangle is that, given that these two angles in here are 60 degrees? Well, if those two angles are 60 degrees, we know that all three angles of a triangle have to add up to 180. So this triangle, EGD, has to add up to 180, and we know two of the angles are 60, so we can solve for the other angle. I'll just call it X, and it turns out that X has to be 60 as well. And so we see what kind of triangle is formed in there. Aha! When all three angles are 60 degrees, we know this is an equilateral triangle. Now the cool thing about that is we know side length ED. We know one of the sides, and in an equilateral triangle, all the sides are the same. So we know GD has to be 10, GD, and we know GE has to be 10. All right, so that's pretty cool. All of a sudden, we have some more information there. Now, I want you to look at one of our larger triangles, and it doesn't matter which, but I'm going to have you look at triangle FAD, this one right here that I'm going over. All right, so we already know, because it was given, that that is an equilateral triangle. Now, let me ask you, do we know any of the sides? Well, not directly, but if we know FE is 10, and we know ED is 10, and those things added together produce one side of the triangle, we know that that one side of the triangle is just 10 plus 10, or 20. And since it's an equilateral triangle, then we know all the sides have to be 20. So AF is 20, and AD is 20. If this part is 10, if GD is 10, and GD plus GA have to equal 20, then AG is 10. All right, and then we can do a very similar thing with triangle BCE, this triangle here. We know that EC is 20 inches based on the fact that ED is 10, and ED plus DC, which is also 10, makes up that side. So the whole side is 20 there. So EC is 20, and again, BCE is an equilateral triangle, therefore all the sides have to be 20, so BC is 20, and BE is also 20, so if this part of it's 10, then this part up here also has to be 10. All right, and now we have everything labeled that we need in order to find the perimeter. And remember, we're looking at we're looking for the perimeter of this. outside portion here. All right, so the perimeter is just going to be equal to AF, which is 20. Perimeter per, I'm gonna shorthand it to per or peri. I like peri. All right, so the perimeter is going to be AF, which is 20, plus FC. Now let's make sure we get this right. FC is comprised of FE, which is 10, plus ED, which is 10, plus DC, which is 10. It's easy to mess that up. So that's where labeling is important. And actually, I didn't do a very good job. This is a hot mess, so hopefully you're better at labeling. And now I'm lost as to what I'm doing. 10 plus 10 plus 10. BC is 20. And then what haven't we gotten so far? BG is 10, and GA is 10. And if I add all these things together, I get a perimeter equal to 20 plus 30 plus 20 plus 20. And if I add all this stuff together, I get 50 here, plus 20 is 70, plus 20 is 90. And that would be in inches, but we don't have to use units when we're doing grid-ins. So our answer, now I'm going to flip this around, our answer, that's an interesting word, is equal to 90. I've never thought about it, the answer was spelled weird. I've always just taken it for granted, but that's interesting. Okay, so our answer is 90. Done with another grid-in. How exciting is that? And that wasn't too bad. Really, the important takeaway here is that we label all that we can and make sure our diagram doesn't get too messy. Make sure we can read everything we label. And if we do that, as long as we know kind of some of the properties of equilateral triangles, we should be able to get this thing.